Hello and welcome to another physics video. Today's lesson is going to be about the behavior of waves, and we're calling this part 2 because in the previous lesson we had talked about what happens to waves when they either enter a new medium or hit a boundary. Well, today what we're going to talk about is what is the difference between reflection, refraction, and diffraction. And we're going to start talking about wave interference and get a better understanding of what that exactly entails. Okay? So I know you guys have probably thrown a rock in a pool before or a pond, and if the water is real still, you throw the rock in and you create waves. And water waves, just like waves in a rope, have crests and troughs. And as the water travels outward from that point that you threw the rock in the water, what happens to those waves when they hit, say, like a barrier, whether it be the side of a boat, the shoreline, whatever the case may be? And here you can see a picture of basically some water waves traveling in this direction, and they're headed towards this barrier. What's going to happen? Okay. Well, there's a law for that, and the law is the law of reflection, which basically says that waves will always reflect in such a way that the angle at which they approach the barrier equals the angle at which they reflect off of the barrier. And once we get into talking about light, this will be something that you guys use quite a bit. But for right now, all you really need to know is that if you have this incident ray, which is this water coming towards this barrier, it's going to reflect off at the same angle at which it hit the barrier in the different direction. And so here in this picture you can see the reflected ray. And what we're going to learn about actually is there's this thing called the normal, which is just perpendicular to the barrier. And this angle that exists right here is going to be the same as this angle over here. All right. As we get into light, we'll talk more and more about that. But just keep in mind for right now, the law of reflection says that waves will reflect at the same angle at which they approach the barrier. So the first thing we're wondering about is what is refraction? Okay. And refraction of waves involves a change in the direction of waves as they go from one medium to another. Remember that the speed of a wave is dependent upon the medium and nothing else. Okay, so here we have some deep water. Okay, and you can see here's a wave, or we'll say that this is a crest. This is a crest of a wave. Here's a crest. Here's a crest. And as it enters the shallow water, you'll notice the crests are much closer together. And so what's actually changed is the wavelength of the waves have changed. And that's partly why you'll see actually waves crest as they get closer and closer to shore, is because it's getting shallower and shallower and shallower. And so the wave length is actually decreasing. Okay. And also actually you'll notice that the waves actually change their direction. They bend a little bit. And that's called refraction, that bending piece of entering into one medium or from one medium into a new one. The second type of thing we have to talk about is something called diffraction. And basically diffraction involves a change in direction of waves as they pass through an opening around a barrier in their path. Okay? And so here you can see water waves traveling this direction, okay, and they're going to go through this opening. And as they go through this opening, they start to what's called diffract. Okay, they produce a pattern something like this. Okay, and this amount of diffraction increases with an increasing wavelength. So if we separate these further apart, you're going to have a greater diffraction. If you put the wavelength closer together, you have a shorter wavelength, the amount of diffraction actually decreases. Okay, so diffraction is just basically the change in direction of waves as they pass through a barrier or an opening. So now we get into this thing called wave interference. You know, obviously, typically, like there'll be many sounds or waves in like a pond or a pool or whatever the case may be, and it's not just one wave. So when these waves run into each other, what happens? And when they run into each other, they interfere with each other. Okay, and we're going to learn about two types of interference. There's something called constructive interference and destructive interference, and their amplitudes, basically, in a nutshell, will add to each other. And I'll show you some examples of this shortly. But first, we're going to talk about this thing called the principle of superposition. Okay, and basically what this principle says is when two waves interfere with each other, the resulting displacement of the medium at any location is the sum of the displacement of the individual waves at that same location. Okay, and that's a mouthful, and it sounds way more complex than it really is. Once I get to some example problems, you'll, I think, see that this isn't so bad. But basically, the principle of superposition basically says that these, the amplitudes of the waves, you add them together. Okay, whatever they are, that you add them together. So let's take a look at an example. Here we've got a wave on the left going from left to right, traveling in this direction, right? And it has an amplitude of 5 centimeters. And here we have a wave on the right traveling to the left, and it has an amplitude of 10 centimeters. Okay, when these two waves hit each other, they're going to interfere with one another, and this is actually going to be called constructive interference, all right, which is the title of the slide, constructive interference. And you just add these two. 10 plus 5 is 15, and so you get like a super wave for that point. When these two waves interact with one another, you get a super wave, and that's called constructive interference. You're constructing something. Okay. Well, what's the opposite of constructive interference? Well, I got some examples of constructive interference. Hang on a second here. So here's a picture of a pool, and you can see, like, here's just in this area kind of just waves moving around. But here we must have some constructive interference going on because we're getting those waves large enough to splash outside the pool. Okay, kind of cool. This is a short video clip I just want to show you guys. Here's we're on a speedboat, and this is kind of like the wake of the boat coming off the boat, and basically when they run into each other, this is constructive interference. This is a great place to do some jumps if you are say like on a jet ski or something. So there's a video of a guy doing some jumps off this thing. It'll be about 10 seconds. All right, so I mean that's possible because the waves are constructively interfering with one another and are getting a bigger wave than what really would be created just on its one wave on its own. So the opposite of constructive interference is destructive interference, and basically the waves are out of phase with one another. And here you've got a wave traveling from left to right, and this is its amplitude, and a wave traveling from right to left, and this is its amplitude. And basically these two will run into each other at this point here, say P, and basically there will be no wave at all because they completely cancel each other out. And this actually, if you buy the really expensive headphones, they make headphones that kind of sense the sounds in your surrounding, and they will actually then create waves to cancel out the sounds in your surroundings so that you don't actually hear anything, and those are called noise canceling headphones. So there are some cool properties to this type of destructive interference. The other thing too is like when they like Navy SEALs and stuff, when they go in on like super top secret missions and they don't want to be heard, their helicopters actually have devices on them that will make noises opposite of or be out of phase with the same noises that are being produced by the engine, so it makes them quieter. It's not like they're dead silent, but they're quieter. And so it's kind of cool that they're using this physics property to again be able to kind of sneak in behind enemy lines and not be detected. So here's some questions for you guys. Where in here we have two waves, okay, and I've got points listed on this wave. Where will you get the greatest constructive interference? At what point would that be possible? And if you look through here, yeah, this would be some constructive interference, but I don't know if that's the best. B, doesn't look like really any constructive interference. C, you've got a little bit, but D, you'll notice these two waves are both peaking at the same point. And so you're going to have a lot of constructive interference there. You're going to get a really large wave at point D. So you would say point D. Where will you get the greatest destructive interference? Well, now we're looking for the waves to be out of phase with one another, and I'm thinking point B looks like a good spot because this wave is going up and this one's going down. And so they're basically going to cancel each other out for the most part. So I'm going to say point B. If we take a look at this slide here, it asks what will the resultant wave look like when the two waves are at the same place at the same time? Well, again, principle of superposition here. We're just going to do a little addition problem. This wave has an amplitude of 3 centimeters. This wave has an amplitude of -5. So what's 3 minus 5? Well, that's -2 centimeters. I have equals twice. I don't know why I did that. Negative 2 centimeters. So it would look something probably like, I'm not going to be able to draw this perfectly, but something like this. Okay, basically some of this wave is going to get canceled out by this, but there's still going to be some left. Here we've got some pictures of just waves on top of one another. Again, just showing you what constructive and destructive interference looks like. So if you're confused about this, maybe spend a little time on this picture and just take a look at stuff like this is an example of constructive interference where the two waves are both peaking at the same time. Here's an example of destructive interference, okay? And again, destructive interference here too. So I mean, it's all over the place. Take a look at this picture. If you're struggling with this idea of the principle of superposition, this slide might be useful for you. All right, and so that takes care of this video. I will see you guys next time.